According to a 2009 statistic from the World Health Organization website, there are 314 million people in the world who are visually impaired. Out of those 314 million people who are visually impaired, 45 million are considered completely blind. A search for a cure has been a mystery to scientists for hundreds of years, but not until 2009 did a huge breakthrough become public. An electronic eye created by scientists at MIT and Harvard Medical School has been developed that is allowing the blind to be able to see again. Today, I will enlighten all of you on the major two causes of blindness, what makes up the electronic eye, and how the electronic eye combats problems blindness causes. To learn how the electronic eye works, we must first know why it had to be developed. Blindness presents itself in many ways, but we will look at two specific events. Retinitis pigmentosa, commonly known as RP, and macular degeneration are the two most common forms of blindness. RP is a hereditary disease that causes the retina to degrade, according to the Britannica Online Encyclopedia. The same source also says that rods in the eyes are destroyed early in life and that the rods are used in the eye to see in dim lighting. With rods destroyed, it causes night blindness. According to a 2009 article written by Dr. Marilyn Hadril on allabouteyes.com, macular degeneration is when the macula degenerates. Hadril goes on to say that the macula is part of the retina that is focused on central crisp pictures. Basically, you can see everything in their peripheral vision, but we cannot see things that are right in front of you. There are two main types of macular degeneration, dry and wet. Hadril says that dry macular degeneration is when the macula thins or when there are deposits on the macula. She goes on to say that wet macular degeneration is when blood vessels grow underneath the macula and leak blood. Now that we know what causes blindness, we look into the electronic eye and see the main two components of the electric eye and the glasses. The electronic eye is a very complicated piece of technology. The prototype consists of a titanium microchip, electrode array, power and data coils, and a flexible substrate. This is according to a review of the topic made by mydigitallife.com. The wires in the eyes are 10 times smaller than a piece of hair, according to an article written in 2004 in the Harvard Gazette by Dr. William Cromie. Something I found interesting in this article was that during early tests, people were awake during surgery so that they could describe to scientists what they were seeing during their surgery to put the eye in. Surgery consists of a small incision next to the eye socket and the chip being attached to the retina of the eye. The question is, how does the eye actually get these signals? According to the top 10 inventions of 2009 in Time magazine that was written by Jeffrey Klunger et al., the person must wear glasses that has a very tiny camera on them. Now that we know what is all in the electronic eye, the key now is to know how these components help reverse the impacts of RP and macular degeneration. The job of the electronic eye is to mimic the retina and send signals to the optic nerve of the occipital lobe of the brain. According to Kluger's et al. Article, the camera sends messages to the chip, which fires the messages down to the optic nerve, which is remarkable technology. This is key because the electronic eye can pick up the slack of the retina, which has been damaged from RP or macular degeneration. In the article written by Dr. Cromie, he talked about the challenges of development. Cromie talks about the challenges of trying to figure out what environmental cues trigger what parts in the occipital lobe. An example is what different parts of the occipital lobe are triggered when you see a car or a tree. This is why it took almost 5 years of heavy research for the eye to become public. Early skeptics of the product said that patients weren't actually seeing anything, they just wanted their eyesight back so badly that they were remembering what they had seen previously, but not actually seeing them. It's important to note that Kruger et al.'s article mentions that this implant will not make a person's vision perfect, but they will be able to move around in a room without complications. After today, we'll all have far more knowledge on the major two causes of blindness, the components of the electronic eye, and how the electronic eye combats the problems blindness causes. Within the years to come, this technology will be perfected even more and become readily available to the public. Because these diseases are genetic, it's possible that you or someone you know will have eyesight problems related to RP or macular degeneration. Annual vision exams and being mindful of one's medical history are proactive actions that everyone can take to monitor for the presence of these serious diseases.